Do you remember what isosceles means? Gee, I wonder. Isosceles. Let's see if we can figure out what isosceles means. Some of you out there might know what isosceles is, but you know what? I want to take this one step further. Check this out. Okay. Consider the isosceles triangle KLM. Now, if you're not sure how to label a triangle, it's real simple. Follow the letters. It's KLM. So start at K, go to L, there's M, and there's your rest of your triangles. So it's got to be labeled that way. Now, check this out. It says that KL here, let me just erase this. It says that KL is 20. So from K to L here, that's 20. 20 centimeters. L to M here is also 20 centimeters. Now, wait a second. That just gave away the definition of isosceles. Isosceles means two sides that are equal. Aha! And look at KM. KM is 30. Now, I got a question to ask you. Where's the right angle? Well, if you're really, really smart, you realize there is no right angle on this one. That guy looks like a right angle, but no, not even close. You'll see once we finish this out that that, in fact, is not a right angle at all. So what do you do in a situation like this? Well, you know what? Make it a right angle. One of the coolest things that you can do with an isosceles triangle is this. You can actually drop down right down the middle there. You can do a nice 90-degree line. Why? Because it's isosceles. Those two are the same. You drop your 90 degrees down, and guess what? That splits this side right in half. That's 15 centimeters. That's 15 centimeters. And lo and behold, look at that. You've got isosceles triangles now. So the question A says, why can't we use SOHCAHTOA? It's not 90 degrees. There's no right angle. You can't use SOHCAHTOA unless you have a right angle. But the cool thing is you just made a nice, beautiful right angle triangle right there. So guess what it's going to ask you? Well, let's go find out. The question says, determine to the nearest degree, so we're going to definitely round this, the measure of angle KLM. Well, KLM is this angle from here to L to M, this whole thing. And it even suggests something for you. Split this. Well, we did that. We split it into two congruent triangles. So if you split this, that means this angle here and this angle there, guess what? They match. Yay! So I'm going to just draw this triangle right here. One more time, I'm going to pick it up and I'm going to move it over here, and I want to show you something. There it is. Let's see if it'll work for me. Oh, of course it does. There's the nice 90-degree angle that I just drew. This guy is 20, right? This guy, in fact, is 15. I want to find this angle. Why? Because if I find that angle here matches. So if I find one of the angles, all I have to do is double it. And I got the other angle. Yay! Right? So let's solve this. Here we go. Eyeballs. There's our hypotenuse. I want to find this angle up here so I can double it and find the complete angle. Okay. Find that angle right there. Eyeballs. There's the opposite. Remember, SOHCAHTOA. You got it, baby. Let's go. Look at this. I want to find this angle here. I've got opposite. I've got hypotenuse. Sine it is. So the sine of that angle, and you know what? I don't know what that angle is because you can't call it L. L is this whole thing. So you got a little corner there. Let's just call it theta for now. Okay. Opposite is 15. Hypotenuse is 20. Let's go figure this out. Got my calculator handy here. We're going to go inverse sine, of course, of 15 divided by 20, bracket, punch it. Look at that. I got 48.59 degrees. Let's go. This guy right here is theta is 48.59 degrees. Now wait. We have not found the whole thing. We've only found a corner of it. So remember, we have to double this thing. But you're probably saying to yourself, well, wait a second. This is supposed to be to the nearest degree. Well, folks, you can't round this yet. You're right in the middle of the question. You only round at the end. So let's bring up the calculator again. Let's multiply this by 2. We got it. Aha! 97.18. Now let's round it. In fact, this works out to be, this angle here works out to be exactly 97 degrees. And that supports this question. Why can't we use SOHCAHTOA? Because that angle's not 90, it's 97. Aha!